Uh, I would like to share my experience on the section of fine-tuning. I'm going to talk about purely based on my experience, how we did it, what we did it. Especially, I want to spend more time on what should not be done. So, these 3 points I want to focus more on, though I'm going to cover other aspects also, but these 3 points I'll give more focus on. What is LLM fine-tuning, and when we should not do it, and how do we do it? So we did a lot of experiments, and the motivation of all the experiments are these. How do we increase the accuracy of the language model output? And then once you are in production, when the data changes, so then how will you manage on the fly? Second piece. And model is expected to make mistakes. If your model doesn't make mistakes, something is wrong in the model. So how do you identify those things and then correct that? I'll spend very few seconds on what is pre-trained model and then fine-tuned model. Then I'll go deep into it. So pre-trained model generally done by big service providers, the model providers. Example, OpenAI, Azure. They take humongous amount of data and then they train the model in the with large corpus of data. So then 80% of the cases, that's enough. You don't have to do anything more on that. You just do the inferencing, meaning you do the prompt engineering and prepare the prompt and interact with the language model and get the results. Enough. The second section is you take that base model and modify some of the parameters and deploy it as a new model. Then that will be the fine-tuned model, very specific to your domain use case. So the one point, the difference between base model and the fine-tuned model is that the base model has not seen your business data. The fine-tuned model has seen your business data, and some of the parameters of the base model is changed. That's all. So I just want to zoom in, and how do we do the fine-tune? First we prepare the training data, then we take the pre-trained language model, then fine-tune the language model. There are techniques, I'm going to cover that in detail. Then very importantly, the final step is that you validate, then deploy. And why we should do this is that these 3 points, the pre-trained model may not be accurate for your use case. So 80%, 82%, no matter what you do, you won't be able to increase the accuracy beyond that. So then the challenge is, how will you increase your model performance beyond the initial accuracy one? Second thing is that you want to reduce the cost. You want to increase the accuracy and you want to reduce the cost. So this is the actual experiment that we did. This is the use case that we did it for one of our insurance use case. TLM stands for Tiny Language Model. What we did is that we took 5.3 model and then used in this experiment. Before that, before the technical details of it, I'll explain the use case. Use case is very simple. The client sends the email to the insurance service provider asking some details. I submitted the claim, what happened to my claim? Or he may ask some other information about the insurance, policy details, etc. So this is the email which comes from the client to the insurance service provider. Then the agent looks at the email and generates the response. When we generate the response, actually it has 3 steps. Step 1, you have to identify the intent of the email. Is he asking a question or related to the policy, or is asking some other information about the claim submitted? These are all some of the few examples that I can call out. Once the intent is identified, then you need further information to retrieve the information. So you may need insurance number, you may need date, you may need some other, the root cause of the claim, etc. You extract these 2 things. And the third piece is that with these 2 information, you go to the structured operating procedure document and get some additional information. All 3 put together, you give it to language model and get the answer. So this is the use case. First we tried with base model 5.3.5, and it gave 82.9% accuracy. Then we calculated the hallucination. Hallucination is one or other way linked to the accuracy also. If it generates anything irrelevant to the use case, then we call it hallucination. The definition differs from use case to use case. The third one is the responsible AI score. So we have pre-set of questions to test whether the model is safe or unsafe when it generates the response. So these 3 things were tested. Then we fine-tuned the model with 7,000 samples, synthetically generated. We used again language model to generate the synthetic samples. To ensure we have wide variety of pattern covered in the data set, we used all major language models, GPT, 4.40, Anthropic Claude, Gemini, Mistral. These large language models are used to generate very high quality synthetic data that is used for fine-tuning the model. After generating data, we eyeballed, we gave it to SME, ensured that the data covers the pattern that we want to do. Then we fine-tune the model. So the accuracy increases close to 14%. The hallucination drastically reduced from 26% to 4%. And the responsible AI score slightly reduced. Is that a concern? Yes, it is a concern, but it is negligible in this case, okay. The point what you have to notice is that 96.44% accuracy, it's n-fold cross-validation that we did. You will not be able to achieve using prompt engineering at all. So the step 1, you do the prompt engineering. After that, if at all you want to increase the accuracy and reduce the cost, then you don't have other option other than fine-tuning the model 1. Second thing is that it reduced the inferencing time also. So when you fine-tune the model ensures that most of the data gets into one execution path. It makes the matrix of the weights 0 in other places, therefore the inferencing is faster. And the model size is drastically reduced. I won't say drastically reduced, it is reduced 3 GB only. And now you can use just CPU to do your further inferencing. The second use case is RAG. Before that, most of the times I get the challenge from the counterparts or various different channels. I have a use case, can we fine tune? That's not the right way to start with. The reason is fine tuning requires a very solid definition of the use case. So in this case, initially, okay, let me explain the business case. There are 2 kinds of question answering. One is fact-based, another one is procedural-based. You give a piece of text which has some information and you ask a question, then you get it. That's a fact-based. Procedural meaning, you have 500-page document and you ask some question. That question has the answer in multiple pages. Page 1, paragraph 2 has some hint. Page 20, paragraph 7 has some information. Page number 400, paragraph 1 has some information. You have to collect all those things, accumulate all of them in one place, then you generate the steps to solve the challenge. Example, washing machine manual, maybe 10 or 12 page section, but when you ask a question, it has to consider multiple section and then come back and give a steps to solve that. That is called procedural questions. It's very, very tricky, and it is not easy to solve using typical prompt engineering way of solving it, and NLP conventional techniques will not help. The fine tuning will be able to pick it up. So if you look at the accuracy increased from 62% to 84% in GPT 3.5, very interestingly, it is performing much better than the GPT-4o Turbo. That's the latest, not latest, 4o is the latest one, but I'm sure it will be better than the GPT-4o also. This is the accuracy that you can never achieve using the prompt engineering. The second one, the procedural thing, even the bigger fine-tuned model struggled a lot. It gave only 62.5% accuracy, whereas we got 75% accuracy using this. So this is two use cases. I just want to give some evidence that fine-tuning is actually working and helpful. This is not my agenda. My agenda is when you should not fine-tune. That's the next piece. So if at all you want to increase the accuracy, the step one is prompt engineering. You do the prompt engineering and then create a benchmark, have some numbers, how it works, and try out different models. The second one is try out alternative approaches also. So if RAG is possible and meaningful in your use case, then you should try. Then conventional algorithms using the embeddings, the numerical representation of the data which is given by the language model, you should still take it and use it. The third one is, using these two methods, you can easily generate the synthetic data which is equivalent to human labeled data. Then the fourth step is model fine tuning. So many times when I get the challenge of fine tuning, the fine tuning is not the business call. Actually, the fine tuning is the data's call. The data has to take a decision. Should it meet the fine tuning or just the prompt engineering? So this is the most important piece in my session. First, you identify the appropriate use case for the fine tuning. All the use cases do not need fine tuning, and important aspect of starting with the prompt engineering. Then this is the climax of my session. The common signs indicating readiness or unreadiness is the next slide. So many times that the challenge itself is not defined very clearly. They say that I have a challenge, can we fine tune a model? One of my colleague mentioned that he got a question from some of the stakeholders, are we using RAG? He said no. Can we use RAG? No, RAG should not be decided whether can we use or are we using it. Just because we are fond of using RAG, it should not be fixed in our challenge. So I get very often 90% of the use cases that I deal with are engineering challenges. I review the use case and give a justification. No, this is not AML challenge. It's a simple engineering. If-else rules can easily solve. Language model is overkill. So defining the clear business case is the first step. No matter what you are doing it, if it is a AML challenge, then the first step is important. then understand that fine tuning has a lot of upfront cost. So data preparation, and then fine tuning the model, cross validation, taking the SME input is very costly. The second one is, if you don't create a benchmark of your results, then you won't be able to conclude whether the approach is reasonable or not, whether it is useful or not. Is it really helping you, or it is overfitting? So trying out different techniques possible, easier, then you decide whether the RAG is useful or not. So this is universal challenge, that the challenge itself is not defined, and when we get into the next step, data is not there. Then sometimes fortunately we get the data, but it is not labeled. If somebody is ready to label, it is polluted. If somebody is ready to label, and if they label the data, the accuracy of the labeling is pathetic. And we end up in identifying what went wrong in labeling, and then identifying back and forth call. So then you can imagine my expression, you can understand my expression. So then instead of fine tuning, we end up teaching the statistics to the entire world. Why it should be labeled in this way, why it should not be labeled in this way. We explain the business back to the business people. No, this is not the scenario in your business case. This is the scenario, actual scenario in your business case. If you don't do it, this will happen. Then they think that, okay, there might be a way this guy doesn't know. Okay, okay, yes, correct. And then unresolved issues in alternative approaches. You try out something and you face some barrier. Okay, then okay, let's find up this, we go to fine tuning. No, fine tuning has bigger challenge. So if you explore something, you have to explore all the alternative options, and then ensure that you reach the final number, benchmark that number, then you fine tune the model to compare against. Then once the model is ready, even this is the case happening with the prompt engineering also. Okay, the solution is ready. How will you say the solution is success or not? How will you measure the performance of the solution? How will you say that it is 80% accurate or 90% accurate? Statistics gives a recommendation, use F1 score, precision, recall, but that's not enough most of the cases. You should get that accuracy some way, one or other way, from the SME, from the business, otherwise your solution will not fly. So defining the success criteria is extremely important, no matter what technique you use. So if you meet all this criteria in a positive way, then you are ready for fine tuning. So now I talked about what is fine tune model, then what should not be done. Now if at all you fine tune, actually what's happening inside. So in one of my session, I gave a presentation. The presentation has one block, one square, and one arrow going inside and one arrow coming outside. Input and output language model, and then I mentioned numerical representation. The session is over. I got a feedback, Prakash, the session is okay, but it is too technical. I went and referred my PPT. It's a box, one arrow going in, one arrow coming out, and then it is too technical. But I'm going to talk about that now. So we use a concept called low rank approximation. So I'm trying to simplify as much as possible. We use neural network. A type of neural network in this case is called transformers. How it works is that it is a matrix. and matrix has a lot of numbers, and then you get the number, you get the input. This matrix will be applied on top of that. It will work as a filter and then extract only the pattern and give you the final output. That's the simplified way of neural network. Now if we go on, you can imagine that it is 1 million cross 1 million matrix. It's very gigantic. The number is not right, but it is even bigger. Now if you touch and modify every number, it's not worth it. It is computationally heavy. So what we do is that we have one small matrix outside, and then we play with that matrix. That matrix and this matrix combined together will give you the final output. The new matrix is something we are trying to learn, that is called low rank approximation. We only play with the small. In another ways, you can say that I'm not going to touch the actual learning. I'll create a small portion of my business knowledge and I'll play with that. Both of them put together will give the final output. So this is how it is possible to manage the fine-tuned versions for all of you, because the large language model is computationally heavy and it is not easy to host. And it requires very high quality data. The number of samples may be reduced, but the quality of the data should be very high. So here I want to take a small break. I'll not go out, don't worry. I want to just recall some of my experience in the college days. My roll number is 18. 1, 2, 3, 4, some prefix 18. By the time the professor reaches 18, I sleep. I'm very famous for sleeping in the classroom. My professor observed me several times. He's my HOD and he became a principal. I'm in touch with him now also. It was, I remember very clearly, it's a DBMS class, RDBMS, DBMS, and he was explaining atomicity, the concept of atomicity. He found me sleeping extremely deep. Then he asked me and he woke me up and asked few questions. Fortunately, I answered all the questions. He wants to ask some question and send me out. But I answered. It is not only the surprise to my professor, my friends also surprised. How come this guy answered? He asked another question. I answered. Then my professor got offended. Then he asked me to sit. Then I sat. Then it happened in the next day also. I slept again. Then he asked me some questions. That day also I answered. Then he started liking me. He asked me, Prakash, come here. Go and wash your face and come and sit. I have no concern. I went out and I washed my face and came back and sat. And that gave me a very good relation between me and my professor. He started liking me. I became one of his pet student. So why I say is that sleeping in a session is not offense. You can sleep. Coming back to this session, the potential dangers of this one is, if you make certain, if the data quality is not good, then instead of doing good, it will damage the language model. So ensure the quality of the data is very good, then you can use it. So human in the loop, it is something unavoidable. 2 weeks ago, I met my former CEO. His name is Tiger Tyagarajan. And he made a point. And I learned a lot from that one single line. AI is useful when the review cost is low. AI is not useful when the review cost is very high. It's a very good insight. I'm bringing that here. I'll give you an example. Let's say you have a invoice line item and you have a purchase order line item and you want to match, and that's a use case you are trying to solve. You can easily flash to the SME, you can look at it, and in a fraction of a second you can say, it's matching, okay, yes. Review cost is very low. Let's say you have 500-page legal document and you are arguing on behalf of your client, and you use the LLM to ingest, you ingest that entire document into the LLM and take 7-8 points notes. And if you want to review and ensure that nothing is missed, then you have to go through all 500 pages. So the review cost is very high. The AI, the returns will be very high. The returns will be very low, and the idea will not fly. So selecting the right use case for the large language model is super important. And then this is what I just covered. And the next point is when you prepare the when you select the use case. Let's say you have 3-4 options of selecting one use case. The third point is something you can consider and look into. So let's say you have 1 million invoices. I strongly argue to all my stakeholders very often, this LLM solution is not autopilot. Somebody has to be in the loop. They have to review. Only then we can say, because I cannot guarantee, it's not mathematical challenge, it's a statistical challenge. It may be correct or it may not be correct. You cannot rely on the confidence score also. It can tell wrong values with very high confidence. There is a challenge. But if you can take certain risk, let's say I process 1 million invoices, I will put certain invoices in autopilot mode. If it is less than 10 USD, I will not review it. It can go. I am okay to take that risk. That's the risk assessment you can do, and ensure your review process is less cumbersome. Continuous learning. This is also yet another tug of war in most of the projects. Now the solution is ready. Tell me how my solution will learn on the fly. So there are two options. One is reinforcement learning. The another one is continuous fine tuning. There is a difference. The reinforcement learning will sit outside another neural network which will sit outside and then fine tune the language model. The continuous fine tuning is we accumulate all the data and collate all of them and go back and use the same model and fine tune again and again. The reinforcement learning is useful when multiple outputs are possible and all of them are correct. Example, if I give you a document and ask you to summarize, you will summarize it in one way and I will summarize it in another way. Both of them are correct. So then you have to leave the decision to the business. The business can say both of them are correct, but I like this one is more correct. Then they can give a feedback. That is reinforcement learning. Translation is yet another example. You will translate one language to another language in one way. I will translate this in a different way, but both of them are correct. So this is the case, to keep it simple, in statistical language, if you have one X and multiple Y possible, then reinforcement learning is ideal. Continuous fine tuning is when you have the data and you get the continuous feedback from the business or somebody reviews it, then you can take and accumulate all of them and fine tune the same model again and again. One point you have to ensure is that when you fine tune the second time the same model, you have to ensure that the previous learning is not lost. So in the validation set or in unit test cases, you have to put certain information or checks to ensure that it is not forgetting the whole thing while learning the new things. So validation. So we used Azure Open AI Studio. I wanted to talk about that in detail. but later I changed my mind because it's not easy to digest all of the information, but I'll give you a few steps. It has the monitoring APIs, it has the continuous pipeline. The one we very often use is prompt flow. So it has pre-processing, processing, and post-processing. All of them can be linked together, and then you can use it easily. So evaluating the performance, the fine-tuned model is not easy. If it is a classification, you can easily measure. If it is a question answering, it is trickier. And if it is summarization, translation, it is even difficult. There are scores, blue score, rogue, will give you indication, but it is not 100% reliable. For those cases, we again rely on the language model itself. We take the output, we first calculate the blue score, rogue score, then we use the language model and do the prompt engineering and give the both question and answer and cross-validate it. So the degradation in performance, especially in responsible AI framework, is very important. So when you fine-tune the model, you may create a damage for a responsible AI layer. So when the model is fine-tuned, the model provider generally does these validations. So is it always generating the safe content? Is it generating unsafe content at times? But when you touch and modify certain parameters, then you can break that chain. So you have to ensure that the responsibility, not only for just for testing purpose, very soon your auditor, AI auditor may ask these reports. So you have to ensure that it is in place. Security and privacy. This point I covered in the previous slide also. Ensure once the model is fine-tuned, you have to have a very quality amount of validation data set to ensure the responsible AI layer is not broken. So in our case, what we did is that we prepared 165 responsible AI related questions. We ask something deliberately sexual content, race related thing. There is publicly available, there are many things. You can take that and then give it to the fine-tuned model and ensure that before fine-tuning, how many questions it rightly answered, it should refuse all the questions to answer. After fine-tuning, is that the behavior observed? That's very important. So maintaining the content safety to prevent harmful output is something I just covered. So this is most exciting piece, conclusion, I'll leave. Fine-tuning is useful when you have defined the challenge very clearly, one, and you performed all alternative methods, and you have the benchmark results in place. You have very quality data set with no pollution. You may not need plenty of samples for your use case, but it can be very handful of samples, but it should be hand-picked. And then you have right set of metrics to measure the accuracy. So if your use case meets these criteria, then you can fine-tune. That's all. So this is my display name in LinkedIn. I write articles once in a while. So I would like to stay connected with you all. So if you give friend the request, we can stay connected.